So we got a question from Jack the Froox author. Jack is asking, I know one thing you've started with ProtoFlux but haven't managed to fully implement is DSP systems. Can you elaborate a bit how this will work on a technical level? So this one's kind of interesting. Is what they do is because they're kind of like, general data processing, which is meant to like, do like a lot of kind of heavy stuff, like for example, processing audio buffers, processing mesh buffers, processing, texture buffers. One of the general things in the system is they automatically handle multi-threading and copying buffers when necessary. So for example, if you have, let me just grab a brush. I'm just going to use this one because it's quick to access. So if you have like, nodes, and for example, this does like, some processing, you have like, one input node and another input node, and then like you do a thing with it, So like this does a thing. So like, this one like merges these two signals and this one, does a thing. This node, it, what it does, it doesn't need to create a copy of whatever output of this one is. This one can modify it straight up. So it just can work on the existing buffer. But if you do this, for example, you use the output for two different nodes, this one will do like, something different. The system will be able to detect it and just be able to make like, okay, I need to create a copy of this buffer, because if this one modifies it, then this one will get like, this modified version, and this kind of solves that. But another thing that it does is automatically handle multi-threading. So like, it'll sort of schedule, when you have like multiple inputs, like this can be computed on one thread, because you have a sequence, and this can be computed independently on the other thread. Meaning these two compute in parallel, and then like once this has all the inputs it needs, only then this one will compute, and once this one computes, this can actually start two more threads, and then at some point it'll kind of merge back up. So like this one computes, and now this can be another thread, this can be another thread, and then like it'll auto like synchronize it at this point, and this way the DSP system, it's going to be one of the things that's going to help it perform like really well. And it's also something that, kind of spreads across different types. Yes.
If you're doing stuff that is like, maybe if it's like simple enough, or if you need it to be fast enough, could you use some of these buffers like on like the stack, for example? Because I do some of that for like some of our audio stuff that is like where I'm like chunking it. I actually do a little tiny bit of processing on the stack because it's way, way faster.
Depends for the node, like probably not across these, because like it needs to be able to move between threads, which means you cannot stack allocate it. But if the node itself, for its own processing, needs to allocate additional buffers, it can allocate those on stack.
Okay.
But like you can't do it like, for the ones, because like it can literally like, it might need to be like, okay, this needs to move to another thread. So like it's gonna use like a pool of buffers. But yeah, hopefully that answers the question.